Everyone ready? Sorry. Okay. Firstly, let's look at practice 4. The question 1 is, please analyze if the mean height of adolescents is equal to 160. For the valuable height, normally we consider the valuable height is the normal distribution. So according to the question, we can use the one sample t-test. Okay, and here is the g-source. One sample t-test, analyze here, compare means, and the second function is one sample t-test. We select one sample t-test here. The test variable is the height, right? And the test value is 160 because the hypothesis is the mean of the height. If the mean of the height is equal, has no significant difference with 160. So here test value is 160. Okay, that's the step 2. It's important, to input the test value 160. Okay, now it here shows the results of the one sample t-test. Okay, through here you can see that the sample number is 30. The mean of the height is 160.66. Here, test value is equal to 160. Yes, correct. So through the results of one sample t-test, it shows that t-value is 0.484 and the corresponding significance is 0.632, which means there is no significant difference. So we can consider that the mean height is equal to 160. Okay, so let's look at GSER's result. Yes? Okay, GSER, here's the data here is wrong, okay? It's not 0.6, it's 0.632. Okay, so please be careful. It's not, it's 0.632. So the null hypothesis are accepted. Good. It's between, it's absolutely correct, okay? Good. This analysis is very clear. Good. Let's look at the question 2. Question 2 is analyze if the mean weight of male and female are equal. Here also, the weight, the valuable weight, it can be considered as the normal distribution. And here, male is one group, female is another group. We have 2 groups. These 2 groups are independent, right? So we can use the independent t-test. Independent t-test, we click analyze here, compare means, independent samples t-test, right? This time we need to compare the weight, the mean weight. So we input the weight into the test variable. the grouping variable. The grouping variable is the gender. Okay, and define the groups. Group 1 is 1. Group 2 is 2. Continue. Okay, and OK. Here is the result of independent t-test. So here is independent samples t-test, right? Okay, also through here you can see that the gender, let's look at the gender. Okay, 1, yeah, so the value 1 is male, 2 is female. One is male, so when we look at the mean of the male, it's 50. The mean weight of the female is 42.68, right? Okay, so here you can see that the male is more than the female. It looks like that. And here is the independent samples t-test. Okay, please. Here shows 2 results. First is this part. The hypothesis is if the variance of 2 groups is equal. Okay, here, so here is the first test. Through here you can see that the F value is 0.936 and the corresponding significance is 0.342, right? Which is more than 0.05. So that means the equality of variance is assumed. Okay, so here is the first part. And then second is this part. Since the equality of variance is assumed, so here equal variance assumed, then we look at the top line of the results. You can see that the t-test for equality of means, the t-value is 2.865. The corresponding significance is 0.008, which is less than 0.01. Okay, so that means the mean weight of female and male is significantly different. Very significantly different. Why? Because it's less than 0.001. If it's less than 0.05, it's significantly different. If it's less than 0.01, it's very significant different. Okay, so remember that for independent sample t-test, it will be divided into 2 steps. First, the test for equality of variance. Second, t-test for equality of means. If the equality of variance is not assumed, so we will look at the results in this line. Okay, yeah. So let's check GSERS. Yeah, here is correct. The result is correct. F value, yeah, is equal. Yeah, good. Step 2, the result of t-test for equality means should, in the case of equality of variance. In the case of equality of variance, t-value is 2. The two-tailed significance is less than, I can conclude that yes, correct. And this question 2 is correct. Okay, good. Jisoo did a good job. Okay. The third question is, please analyze if the mean height of different ages are different. Okay, so here, different ages. For age variable, we have 3 levels. Age 3, age 4, age 5. And also height is normal distribution. When we compare the means of one variable, one factor which is has more than 2, which is at least 3 levels, then because t-test, we just compare 2 different groups, right? But now here we have 3 different groups. So here we will use the one-way ANOVA. Here we can't use the t-test because here we have 3 different groups. We have 3 levels. Okay. So here is wrong. So this part is wrong. Okay. We see. One-way ANOVA. Yeah, this part is correct. This part is correct. Okay, I'll show you. Here, if the height or weight, if the height or weight, let me see. Sorry, I check it. If the mean height of different ages are different, yes, okay. So analyze here, compare means, one-way ANOVA, right? And then the height into the dependent list. The factor is the age. Because we want the hypothesis is if different ages, the mean of the height of different ages is equal. And then options here, please select the homogeneity of Reliance test. Yeah, please think about what we have done in the dependent sample t-test. They are the same step. For one-way ANOVA, we also need to conduct the homogeneity of Reliance test. And here, VF, Welch, you need to select because if the variance, equal variance is not assumed, then you need to use these results. Okay. Okay. So here, firstly, here shows the test of the homogeneity of variance, right? Okay, so here the Levy statistics is 1.409. The corresponding significance is 0.262. Okay, which is more than 0.05. It means the equal variance is assumed. Equal variance is assumed, then we will look at the results of this part. If the significance is less than 0.05, then we will look at the robust test of equality of means. Okay, got it? Got it. It's important. Okay, if the variance is equal variance is assumed, look at the results of this. If the equivariance is not assumed, then we will use the robust test of equality of means. Okay? Okay? Fisher, you lost this step yesterday. Okay, now can you understand? Okay, let's look at Jesus. Yeah, the results is correct. Okay. Okay. Jesus, here is the test of homogeneity of variance. So the analysis is not correct. Okay. So since the value of significance is more than 0.05, hence the variance of different groups has no significant difference. Or you can say that hence the equal variance is assumed, or the homogeneity of variance is assumed. Okay. And then, since the equal variance is assumed, then we can look at the results of this part. Okay, so the observed significant value is 0.072, which is more than 0.05. Here, my suggestion is please write the significance value here. Hence, there was a significant no effect of height. Okay, hence, the height of different ages have no significant difference. Okay, here is the answers for the question 3. Hope you can understand